subtracting, multiplying or dividing measurements, we have to use the weakest link rule to know how many sig figs we should give our final answer to. So the rule is if you are multiplying or dividing, then your weakest link will be the smallest number of sig figs in the given measurements. Smallest number of sig figs in given measurements. Okay. However, if you're adding or subtracting, your weakest link is the smallest number of decimal places. And you say, why? Because if you go to sig figs, sometimes you can inadvertently actually get rid of some precision that you really do have when you're adding and subtracting measurements. And I think this should be a good example of that. So smallest number of decimal places. Measurements. And as a caveat, if you do anything with your measurements that involves an exact number, and by an exact number I mean a constant, like, oh, you're using the speed of light or the molar mass of copper, or you're using a fact like there's, 6.022 times 10 to the power of 23 particles in a mole, or another kind of fact like, hey, if you've got to convert from a circumference to a radius, you divide by 2. Those exact numbers we take as having infinite significant figures, so they don't affect the amount of significant figures in your answer, just as an FYI. So here we are reporting the average volume of a pollutant. Okay, so we are averaging together 3 volumes in liters, which means, okay, that we are actually following the smallest number of decimal places, because the dividing by 3 is not using a measured value. Okay, so I just want to show you what I mean by like decimal places, so that there's, oh, of course it wouldn't like sync up, so I'm just going to get rid of this. So like if we're using ye olde school way of adding, subtracting, 45.5, and we're adding to that 6.00, so this is to 1 decimal place, this is to 2 decimal places, and the last one was to 3 decimal places. Making rhymes with bacon. 3 decimal places. The amount of sig figs they're measured to is all the same, right? That's to 3 sig figs. So is this, so is this. Okay, but they're measured to different numbers of decimal places. So you want to make sure that you are preserving the precision of the measurements, okay? So in this case, if I was to add these all together, 45.5 plus 6 plus 0.989, what do I actually get? I get, and I'm going to try and line it up as best as I can, 52.489. We're going to worry about rounding in a minute. Okay. So in terms of sig figs, if I rounded to the smallest number of sig figs, which is 3 sig figs, I'll get 52.5. In terms of decimal places, in this case, it actually works out the same, right? 52.4. But you'd have to be careful. Like if this was 45.50, then I really should keep that second decimal place, because otherwise I'm actually ditching a level of precision that I had in that measurement. But in this case, it doesn't matter, okay? So I would be rounding to 1 decimal place, because that is the smallest number of decimal places. So that would be bum, 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 bum. Oh, and I've got to divide by 3 as well, because it's an average, silly girl. Divided by 3, so 17.496, blah, 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 blah. So again, if I've got to get it to 1 decimal place, that'd be 17.5 liters. Okay. Okay, so let's do another one, see what else it comes up with. Okay, so again, this is a similar one that you're adding together. So we should go to the smallest number of decimal places, which is going to be 3, and they're all to 3 sig figs. So that's essentially the same question, different numbers. Something different. Okay. So we have to write down the concentration of a solution, and you don't know how to work that out yet. Spoilers. The concentration is the mass divided by the total volume. Okay. We are actually told in the question. So that's useful to know, isn't it? So we've got a mass, we've got a volume, it's going to come out in grams per milliliter. Okay, so our mass is 9.000 gram, and our volume was, oh, hang on, I can't read through here. No. I'm not reading this properly because I've got writing over the top of it. It's a bit more complicated than that, because we are working out the mass by difference. Look, You can go away too. No. Be gone. Okay, so we've got the empty weight of our graduated cylinder. Sorry, this is hard to read. And the cylinder plus the sodium thiosulfate is 70.69. So the mass by difference then is the mass of full cylinder minus the mass of the empty cylinder. You'll do this a lot in lab, right? Cylinder. And that will give us the mass of our, was it sodium thiosulfate? Of sodium thiosulfate. Okay, so let's just make sure we're doing this correct in terms of sig figs, decimal places, etc. The full cylinder was 70.69 grams. So that is 4 sig figs, 2 decimal places. 2 decimal places. The mass of the empty cylinder was 9.000, whatever. Okay, again, 4 sig figs, but 3 decimal places. Okay. So we should only be giving our answer to 2 decimal places for this, okay? Okay, so what is the answer? 70.69 minus 9, 61.69, which comes out to 2 decimal places anyway, but we just want to be aware, right? So 61.69 grams. Okay, so then our concentration was our mass divided by our volume. So we have 61.69 grams divided by our volume, which is only, let's see, 110.0. So again, 4 sig figs and 4 sig figs. So this time we're going on sig figs, not decimal places, because it's division. So 61.69 divided by 110 should give me a concentration of 0.5608188181, blah, 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 and that is in grams per milliliter. I think that's what we're asked for. So in terms of significant digits, we shouldn't go any more than 4, which would be like so. 4 significant digits. Okay, so that will do for that. I think that is enough